Hello, the purpose of this screencast is to help you deal with some of the worksheet problems where an object is thrown upwards and it goes up, reaches some maximum height, and then falls back down to the ground. Okay, so to do this, I'm going to open Logger Pro, and at the same time I'm going to show you how you can use Logger Pro to analyze video. Okay, so once you open Logger Pro, you can just insert any movie. I just made one called Ball Thrown Upwards. I'm going to insert that now. Okay, and I'll make this video large so that you can easily see it. All right, and see here, this button opens the video analysis features. This is like the video analysis toolbar. And I'm going to use this button here to advance to the next frame where the ball is finally actually in the air. It's left my hand. So now I'm going to go to this point to collect data. Click. Every time I click on where the ball is, I'm just trying to click where the center of the ball is. Each time I click, the ball advances by one frame to its next location. Okay, looks pretty good. Ball is still going up. Ball's still going up just a little. Up, ball's going down. So the ball must have stopped somewhere because it was going up and now it's going down. So there it goes. Ball is now moving downward. And I'm just clicking where I think the center of the ball is. And each time I click, the ball moves down. That's a little hard to tell, but I'm guessing. There we go. It's hard to tell, but it's probably around there somewhere. Okay, it's definitely the ball is in my hand now, so I'm not going to click anywhere. Let's look at our data. So because a video camera automatically measures time, all these times are just the time recorded from the video camera. These positions right now, try to figure out what those mean. If you look up here, you'll probably be able to figure it out. As I move from left to right, this number gets large. So mouse position is defined right now. It looks like it goes up to about 800, 770. These are how many little squares we count as we go across from left to right. Now, if I start on the bottom and move upwards, we're talking about this number. Okay, so this is essentially the number of pixels from left to right and the number of pixels from the bottom to the top. So it's a position, but it's in pixels. So I want to convert all of these numbers into meters. So that's what this button's for. It's called Set Scale. And I click on it, and then I click here, and I let go there. And I'm just using the whiteboard as a measuring device. And on the whiteboard it says 92 centimeters. That's the length of the whiteboard that I measured. And 92 centimeters is 0.92 meters. So now I hit OK. And let's see, if I want, I can make the initial position of the ball 0. It doesn't really matter. I'm just going to leave it alone. So you'll notice now all of these numbers, the positions are all measured in meters, the velocities in meters per second. Now the ball didn't really move left to right, so I'm going to take out x, which is left to right, and I'm just going to worry about y, which is essentially the height of the ball measured from the bottom of the whiteboard. And I guess this graph is position versus time, height versus time. And I'll insert graph. I really want a velocity time graph, and I can change this to whatever I want, but it's already a velocity time graph, so that looks good. I'll choose Apple R, and hopefully this makes sense that you got this beautiful parabolic curve for position time and a linear pattern for velocity time in the y direction. So what's happening is as the ball rises, as the ball is thrown up in the air, it gradually slows down until it reaches the top. The slope and the first half of this graph gradually gets steeper. Now these slopes are all positive, indicating that these velocities before half of a second are all positive. We, remember, defined upwards as positive because when we set scale, we clicked on the bottom of the whiteboard and then we clicked on the top. So that makes upwards positive in direction. Then, as the ball falls down to the ground again, or to my hand, it speeds up, right? So in the second half of the graph, after 0.5 seconds, these slopes gradually get steeper, okay? These slopes on your position time graph are all negative, meaning that these velocities are all in the negative direction. In other words, those velocities are all downwards. Now, there's one more really cool thing I could do is simply find the acceleration. You should probably pause the video right now and think to yourself, what's the acceleration of this ball while it's in the air? What's the acceleration while the ball is moving upwards? And what's the acceleration while the ball is moving downwards? Please pause the video and think about that. And look at the graphs for evidence. Okay, so hopefully you thought about what's the acceleration of the ball on the way up and what's the acceleration of the ball on the way down. And in particular, what's the acceleration of the ball at the moment it's at its highest location? Okay, that would be here, right? At one moment in time, when the ball changes direction from moving upwards to moving downwards, from positive velocity upwards to negative velocities downwards, there's got to be a moment there when the velocity is 0. Well, I wonder what the acceleration is at that moment. Well, if you recall, the acceleration of any object is just simply its change in velocity divided by change in time, which is the slope of your velocity time graph. So if I put a best fit line on this graph, because it does look linear, I see that the slope of this graph is very close indeed to 9.8 meters per second per second. It's negative because we already defined upwards as positive and the acceleration due to gravity is downwards. So it looks like each second the velocity of the ball is changing by -10 meters per second. And even at this moment in time, when the ball is not moving for just a moment, even though the ball isn't moving, its velocity is still changing at that moment. You can see from the graph that this is true. Anyway, hope you enjoyed the video, and I hope this helps you with your worksheet problems. Now would be a good time to do number 8, and have a good day.